Hello everybody. In this video I'll be comparing and ordering rational numbers. Again, rational numbers are numbers that can be made into a fraction that have integers on the top and bottom of the fraction. Here the rational number is looking like a decimal, so if we want to compare negative 12.4 and negative 12.65, a pretty common mistake with sixth graders is that they see 12.65 as being larger than 12.4, which is true on a positive scale. So if we were to make this 12 and this 12, well, 12.0 and 12.2 and 12.4 and so on, and 12.6, 12.8. So if this is positive, then 12.4 would be right here, and 12.65 would be right about here. Now when it's on the negative side, negative 12 is here, negative 12.0, and then negative 12.2, negative 12.4, and so on. And so in this case, negative 12.4 is here, and negative 12.65 would be here. So what we say is negative 12.6 is less than negative 12.4. Or you could also say negative 12.4 is greater than negative 12.6. This is preferred just because it follows the number line. A lot of times what you want to do with your inequality to have it make sense is the numbers on the left should be smaller than the numbers on the right, because that makes sense in terms of the picture of a number line. Let's try another one. So let's say we have these two fractions. We want to compare negative 5/6 and negative 5/8. Again, what you can do is split up this number line into sixths and eighths. So what I'm going to do is we'll put 0 here and 1 here. And so if we want to split this up into eighths, I guess we've got 4/8 there and 2/8. So 1, 2, 3, 4, 5, 6, 7. So these are all eighths. So 1/8, 2/8, 4/8, 6/8, and so on. And then we can also split it into sixths. So this here would also be 3/6, right? And then what do we have? I don't know, something like this, 1/6. This isn't going to be perfect, but 2/6, and something like that. So 4, and then 5. Oops, I mislabeled that. 4/6. Okay, so we have 1/6, 2/6, 3/6, 4/6, 5/6. And as we all know, 1 would be 6/6 or also 8/8. Also, notice that this is the positive version. I like to think of things in the positive version and then kind of flip it around to the negative version to see the opposites. So 5/6 would be right here. So here's 5/6, and then 5/8 would be about right here. So we can see that 5/8 is less than 5/6. Now if we flip it around, then we have, it'll be the opposite, right? So if we flip this around, let me see if I can copy that. So now we're going to have negative 1 over here and 0 over here. So we know that the negative 5/6 is going to be kind of this close to negative 1, as we can see there. And the negative 5/8 is going to be, closer to here, negative 5/8. So we can see that our inequality would be negative 5/6 is less than negative 5/8. Also, you can use a little common sense here rather than actually plotting everything out on a number line. If we were just comparing these and it doesn't say that we have to use a number line, this is pretty close to -1, whereas this one is pretty close or just above, or in the case of negative, just below -1/2, right? And so if this is close to -1 and this is close to -1/2, then this has to be smaller. So -5/6 less than -5/8. All right, if we were going to compare something that is a decimal with something that is a mixed number, we have a couple different options. First of all, let's just start with the negative versions now, since we've already gone over kind of the positive and reversing that. So we're in between -1 and -2 here. So here's -1, here's -2. Now we can split this distance into thirds because this is thirds here. Won't be perfect, but something like that. So here would be -1 and 2/3. Now we can also split this distance into tenths because this is 8/10. So we have 8/10, but that's also equal to 4/5. So we could split this distance into fifths. There's a lot of different ways we can go here. I don't know. Let's try fifths, and I'll do that in red. So let's see. Maybe 1, 2, 3, 4, 5. Well, it's not perfect, but you get the idea. We can see that 4/5 or 8/10 would be right here. So this would be -1.8. And so we could say -1.8 is less than -1 and 2/3. Another thing you could do in this case would be to change this to a fraction, which is kind of essentially what we did there. You could also think of this as a decimal, so 2/3, if we wanted to make that a decimal, is a repeating 6. So -2/3 would be -0.6, which is certainly less than or greater than -0.8, right? So another way we can think of it is this. All right. All right, let's try one last here. Order these numbers from least to greatest. Sometimes it's a lot easier than plotting it on a number line. Sometimes you can just see what's going on because the numbers are so far apart. So here it looks like -1.5 is the smallest number we have. So I'll just say -2 here. And the biggest number we have looks like 2.4. So if we had a 3 right here, and then 0 is going to be somewhere around here. So we got -1, 1, 2. Okay. So -0.2 is very close to 0. So that's going to be around here. I'm just going to put it up top for space concerns, but actually we label the numbers on the bottom of the number line. -1.5 is going to be about right here. -1 is right here, so we have these three so far, and then we have 2.4, which is way up here, and then we have 1 3/4, which is about right there. So this one's pretty easy. We might not even have to use a number line to order these. Now, what we can do is order them using multiple inequality symbols. So we could say -1.5 is less than -1, which is less than -0.2, which is less than 1 3/4, which is less than 2.4. And we're done with that. So thanks for watching the video.